point B. Okay, we have to. But before we determine our acceleration, we know that omega and alpha are unknown. Okay, we don't know that. So the best way to find what is going on with, or to determine alpha and omega, is we know that we have a rigid body of points A, B, C, and D on a what? On a rigid body. Okay. So from here, I'm going to take this whole diagram. So from here, we are going to select, okay, we're going to select points C and D to determine omega and alpha, right? Because we are given the what? We are given the acceleration and what? Velocities, okay? So what we try to do now is we are going to do acceleration at point C is equal to acceleration at point D plus by alpha cross R C from point D minus by omega squared R C from point D. Okay. So the first thing to do, we need to what? Need to determine omega first. Okay. So we can use velocity at point C is equal to velocity of point D plus by omega cross R C from point D. Okay. So we are given, let me get this diagram down. Right, so we call this over here our point C, over here our point D. Okay. So velocity of point C is equal to Cj, 6J, Cj, come on. And then D is minus 2J. And this is the omega that we assume it to be. So it's equal to minus omega K, okay, cross C from point D. So it's minus 0.5, minus 0.5 I. Okay. So we have 6J is equal to minus 2J. K cross I is positive, right? Negative become positive, so plus by 0.5 omega J. Okay. So based on J component, we know that this is 6 minus 2 plus by 0.5 omega. So 0.5 omega is equal to 8, right? So omega is equal to 16 radians per second. And because it's positive, the assumed direction is correct. Okay, so therefore we know that omega is equal to 16 radians per second. Okay. I will bring back the other diagram. Okay, now we have to focus on this diagram. Yeah. So now we have to write out the component now. Okay, so now we are going to write out AC is equal to AD plus by alpha cross RCD minus by omega squared RC from point D. Okay. So hopefully from here, we can determine our alpha direction. Okay. So if we look at point C, right, we have our ACN in the I direction. Okay. And then we have plus by 2J. And the whole thing will be equal to minus ADN in the I direction. Because this is pointing towards the left. And then we have minus 3J, right? Because it's pointing downwards. Remember, we assume alpha to be going in the clockwise direction. So we have minus alpha K. Then we're going to cross our point C from point D. So this is minus 0.5 I. And then we have minus omega squared. Okay, so this is 16 squared. And then RC from point D minus 0.5 I. Okay. So now we're going to write this out. So this is equal to AC and I plus by 2J. We don't know our ADN yet. Minus by 3J. Okay. Now, K cross I is positive. Minus minus, so plus 0.5 alpha J. Okay. And then the last component, I nearly forgot. So 16 times 16 multiplied by 0.5. And then minus minus plus 128. And then this is just our I value. Okay. So now given this expression over here, when we do this, it's very easy, okay? It's not that bad. So from here, we can write down that our J component so you have 2 minus 3, okay, plus by 0.5 alpha, right? And then we can solve this. So 5 is equal to 0.5 alpha. So alpha will be equal to 5 divided by 10 radians per second squared, positive. So the assumed direction is also valid, okay? So the clockwise direction is also. And then if we were to look at the I component, right? So we will have AC N is equal to minus AD N and then plus by 128. So ACN plus by ADN is equal to 128. Okay. Now I want to focus on ACN and ADN. Okay, I'm going to try to lift this diagram again. Okay, we know that point C and point D, right, from the center of rotation, which is what? Which is point A, right? Which is this point over here. The radius is equal to what? So the distance from here to here, the radius is equal to 0.25. Okay. So therefore, right, we are aware that A in the normal direction is equal to what? Omega squared R. Okay. And we know that point C and point D are on a single rigid body. So therefore, ACN is equal to ADN and is equal to omega squared R. And the omega we found earlier, okay, omega that we found earlier is equal to what? 16. Okay. So 16 squared, the radius is now 0.25. Okay. So 16 squared, 64 radians per second squared. Okay. So we know that. Okay. Now, the next thing that we have to do. So if you look at this equation over here, right? This is 64. This is 64. It becomes what? 128. Okay. So the last thing that we are going to do is we are going to consider point B and point C. Okay, we're going to consider point B. Now, to solve for point B, right? If you use point D, the answer will also be the what? Will be the same. I just decide to pick point B and point C. Okay, so from here, AB is equal to AC, right? Plus by alpha RB, or not, here, Eugene, cross RB from point C minus omega squared. Okay. So if we were to look at RB, point B from point C, right? So it's equal to 0.25 I minus by 0.25 J. Okay. So that is our point B from C, because the radius is equal to what? 0.25 for that reason. Okay. So I is positive because it's from point C, right? Okay. So from here, if we were to focus at point B, right? We will go focus on point B. We have minus ABTI right? Then plus by A, B, and J. Okay. And then the whole thing